Okay, so this is to help you with the last problem in the formative assessment for today. And so it says the decomposition of H2O2 to water and oxygen was studied at room temperature. The reaction is first order, the rate constant is 0.021, and the initial concentration of peroxide was 0.015. What is the concentration of H2O2 at 100 seconds? Now, if you look at this, one thing it is really important. It says the reaction is first order. So what I'm going to do is I'm going to go to my formula chart and think, what equation shall I use? Well, let's look at the first order integrated rate law. That has the rate constant, time t, initial concentration of A, and concentration of A at time t. Those are all the variables that I need. So I'm going to write this out. Minus the log of A, initial concentration, is equal to a negative kT. So the question is asking, this is my initial concentration, so that will go there. What is the concentration of H2O2 at, and time t is 100 seconds. So we'll solve for this, A at time t, and our t will be 100 seconds. So really this is just plug and chug, but I do want to help you with the natural log function. All right, so I'm going to plug these in. 0.015 is equal to a negative 0.021 times 100 seconds. So this is seconds to the minus 1. This is seconds. All right, so now I'm going to go ahead and start cleaning some of this up. Let's move this one over so I can get this by itself, is equal to a negative 0.021 times 100, okay, plus the log of 0.015, right? Cleaning that up further, I get a negative 2.1. Now, how do I get this value? Remember to take the natural log. All I'm going to do is hit my ln key, put in 0.015 and equals, and that is 4.1997. And I'm going to actually, and notice also that it is a negative. When you start taking logs, especially natural logs, you always have to check your sign because they could be negative and they could be positive. And of course, that's going to hugely change your answer. So make sure you get that right. I'm going to leave it to about 4 past the decimal point here because we don't want to round too much. You'll see these numbers get so small that what ends up happening is that you lose a lot of value in your answer. All right, so I'm going to add these two numbers up. I get negative 6.2997. Now, the trick to this is I am going to take the inverse log of both sides. This is e to the log of A at time t and e to negative 6.2999. Now when I inverse log a log, they cancel each other out. So basically I have A at time t is equal to e to the negative 6.2997. All right, this is easy to solve. Basically what I'm going to do is I'm going to do second log. Notice that gives me e to the what? Negative 6.2997. Enter. That equals 0.00184 molar concentration of A. So the concentration of A at time t is 0.00184 molar.